Hey, my name is Emmitt Antwine and I teach at Haughton High School in Bossier Parish. As an educator, I am most passionate about helping students build confidence in taking risk in a math class. Many of my students have faced significant learning gaps due to the pandemic. Many of the students you'll see in the video today experienced going through the pandemic from elementary to middle school. My goal ultimately is to provide a supportive and safe learning environment for all students to reach their potential in a math class. Because I understand math is not an easy subject to learn, but it is something that all students can achieve. When I was growing up, math was easier for me, but I want to make sure that math is something that they can take with them long before leaving my class. The lesson you will see today is a group of pre-AP students, mostly freshmen and sophomores, learning how to use trigonometric ratios in order to solve real-world application problems. The objectives that we're going to be looking at is calculating the trigonometric ratios and applying that into real-world scenarios such as angle of elevation and angle of depression problems. Before the lesson, students were able to use the Pythagorean theorem and were able to use our tool SOHCAHTOA in order to achieve some of those goals in the prior lesson. To support all of my students, I use a variety of learning strategies such as visual aids, the boards, vertical whiteboards, and just collaborative student working so that they have the ability to achieve those tasks. This lesson is trying to bring a broader approach to math by taking what we've already learned in the prior lesson and again applying it to a bigger context so that they have a better understanding of what we're talking about. And my goal ultimately is to provide more proficiency in math, and that's what I hope to do in this lesson today. All right, I hope you enjoyed that refresher video going over trigonometry, but now we're gonna actually do some practice. So each group has a whiteboard. So I wanna make sure that one person has a whiteboard and one person has the expo marker. We're gonna go through some examples that we've done before. For these examples, what I want you guys to do is write SOHCAHTOA on the top of your board first. So who's ever writing, write SOHCAHTOA. We're going to practice writing the trigonometric ratios for these examples. So for this one, I want you to look, what is our reference angle for this first problem? Angle A. So make sure you're drawing the triangle so you're showing your work, okay? And once you find your answer, you can show it up to me. It's just to verify. Good job. Good job. Great. Love it. Check that one more time. What's your reference angle for that one? There we go. Y'all got this one. So for class, so which is our answer for this one? 4/5. So remember, whenever you're having your reference angle, you can identify each side of the triangle. So let's try another example. All right, can I have someone read us our student goal for our project for today? Any volunteers? Logan.
I will be able to solve real-world triangle problems using trigonometric ratios.
Thank you. So for this particular lesson that we're doing today, we're taking what we learned previously and we're going to be solving some real life application problems because I know a lot of times we do math and we're like, why are we doing it? So we're going to look at some real world examples. I'm going to be passing around to you guys per group 2 examples to look at. So each person's going to get a copy. So you have an option of how you can solve the problems today. You can either solve the problems at your desk as a group, or you can go to any of the vertical whiteboards that are in the back. So what do we know about number 2 about the angle of depression and angle of elevation?
Well, it uses alternate interior angles to get this angle.
And what does that tell us? Because they're alternate interior angles, they are what?
Congruent.
They are congruent. So that means if you know the angle of depression, you also know the angle of what? What else?
Elevation.
There you go. So make sure y'all are looking at that second example there because it shows you how you can label your angle of depression.
It's just whatever's down here.
Yeah, you're looking, that say this line is equal up and down.
Okay.
So that's all it's saying, you know, how you know how it's like a toe? That is this
On the
A
page.
or G. If it's underneath, and they actually said this in the video, you multiply, but if that is over, if you have to, one that's over, which they also said it, but they said you move this to here, but you also can just see it as divides.
I'm gonna give y'all about 1 more minute to wrap up.
My drawing is not that good. And then, let's see, finding the hypotenuse. We have that height, and then there's the base angle.
We're gonna go over these 2 problems to make sure we're having a better understanding of angle of elevation and angle of depression problems. So for the first one, can I have a volunteer to read us the first scenario? Brian, can you read us the first scenario?
From a point on the ground 12 feet from the base of the flagpole, the angle of elevation of the top of the pole measures 53 degrees. How tall is the flag?
All right, so for this one, if we're gonna draw our model, my advice to you whenever you're solving these real world application problems is to make sure you're drawing your triangle models. So if we're going to do this example, first thing I'm gonna do is draw my right triangle first. Out of all of these lines that we have here, which line do you think is gonna represent the flagpole in this example?
Or the vertical way.
The vertical leg. Does everybody agree? Thumbs up if you agree with that. All right. So our flagpole is going to be here. What else are we having to label in our example? What other pieces of information?
Distance from the flagpole.
Distance from the flagpole. So that's what we're looking for, correct?
No, we're looking for the height of the flagpole.
And so what can we put there for the height? Like any variable?
Yeah, any variable.
What variable did y'all choose?
X.
All right. So I'm gonna put X for that one. There are 3 parts to our activity today. We're gonna start with part 1. So I'm gonna have 1 person from each group. Y'all can stand up. Go ahead and take it off the board. Don't be scared. You can work on that question on your whiteboard. Make sure you are drawing out the model first.
Okay, plan.
Number 3. Let's see. Y'all used 32. For this one, double check what you're looking for. The only issue is where your X is
From
placed.
the pilot, the angle of the depression to the airport. How far is the tower from the pilot directly to the... Okay, yeah.
Which is basically what we did on the whiteboard.
Yeah, I would say that.
Everybody is on part 2 right now.
Yeah, that's fire. And it casts a shadow.
So,
You got that.
just make it really dark at the bottom.
You know, 3 circles.
Red. I just cover the whole thing red.
It makes sense to do 3 circles. Why?
Y'all are getting it. Again, let me know if y'all got any problems, okay? All right. I like y'all's energy over here. Y'all got a guy on the fence. And remember, there is one more part to this, and you can look at it on your computers to see what part 3 is, okay?
Okay.
Let's see, we're good, good. Each one of you guys will solve an exit ticket. They're all the same, so you can work together on this one as well. Okay. All right. Need an exit ticket as well? There you go. 2 of them. Here you go. So once you finish, we're going to go over it as a class. And to wrap up our lesson today, I want us to look at our student goal for today. I need y'all's attention. So I need you to look at our student goal, and I want you to rate yourself, just mentally, of how much you feel that you understood or achieved this goal today. 10 being the best, 0 being I didn't really understand anything we did today. Just make sure you give me a number so I understand what you got from the lesson. 10 being the best, 0 being the worst. Y'all can be honest. What about y'all with this group?
It's good at like 8.
8? What about you, Serena? All right. What about you, Isabel? 8. 10. 8. 10. 9. 10. All right. So understand that what we're doing, you can actually use into the real world. So one of the questions that I know people want to ask is, did the students achieve the objectives in the lesson today? And from basically the rating of themselves at the end of the lesson, them enjoying the lesson overall, talking and having those collaborative discussions, those academic discussions in the process, I believe that majority of the students understand how to use what we've learned in the previous lesson, the trigonometric ratios, and apply it in the real world. Some of the misconceptions that I did see was students identifying the wrong side, but ultimately by redirecting them, by using questioning techniques, I was able to do a better job at helping students not have the same mistakes, but making sure that they are reading the question correctly, reflecting over it, and then having the ability to look at what can work and what cannot work, and using their reasonable math skills in the process. But is there anything differently that I would do next time? I think the one thing I would do differently next time would give students the opportunity to work more on the vertical whiteboards. It gives me as the teacher a better insight, and by having me look and evaluating, giving informal feedback, it will provide students with more confidence in them taking more risk in the class. And what happened in the video that you did not see, one of the things that we did afterwards is we provided students the opportunity to work independently. I encourage students to work collaboratively to enter into the lesson, but ultimately speaking, in this class, we want students to learn the skills on their own and have the confidence in order to solve the problems when they have to do it on the real test. And is there anything relevant that you need to know afterwards? Is that my students, yes, they don't have the best confidence, but ultimately as we go through lesson after lesson, they continue to impress me. They continue to do better each and every day. And it's due to the fact that they're able to lean on one another and they're comfortable enough to ask their teacher and their other peers for questions. So I think in this classroom, we provide supportive and a safe learning environment so that all students have the opportunity, again, to achieve something bigger. Hello, my name is Emmitt Antwine. I hope you enjoyed the lesson you watched today. And again, feel free to come to my classroom anytime. Thank you.